right, so last thing we're going to look at is section 6.2, and it's on what we call unit circle trig. So I'm going to explain what that is. There's some formulas we have to go over, and then we'll see how much we can get through. So I'm going to use this diagram to try to explain to you what unit circle trig is. What I'm going to do is I'm going to draw a circle, and I'm going to put that circle right in the middle of the XY plane. Next, I'm going to draw an angle. Doesn't matter, any size angle you want. The point is that the terminal side of that angle hits the edge of the circle somewhere. Where does it hit? Right there. And if you wanted, you could make an arc like that. That's the arc created from that angle. We've found the arc length before. That's not really what we're interested in. What I'm interested in this time is this. That point. Well, if this is the origin, right there, that's 0, 0. To get to that point, it has a coordinate. The x value would be negative and the y value would be positive in this case. Depending on how big or small of an angle you make will change what quadrant that point is in. Well, our goal in unit circle trig is to figure out the coordinate of that point. That's the whole goal. To find the x value and to find the y value. So any question on the goal of unit circle trig? Draw an angle. The terminal side is going to hit the circumference somewhere. Find the coordinate of where it hits the circumference. And then I'll show you what we do with the x and the y value. But that's the first step. And I think I write that all down if you're more visual. So when I say certain angles, I'm talking about angles that are multiples of 30 and 45. That's what you use unit circle trig for. So for any angle that's a multiple of 30 or 45, we can draw it. We can draw the terminal side, and the terminal side will hit the edge of the circle somewhere. So you might get that. Let's draw an angle. Here's a circle. Let's make an angle. Initial side, terminal side. There's the arc in blue. That arc ends right where the terminal side hits the circle. That point right there has a coordinate. In this case, the x is positive and the y is positive because it's in quadrant 1. If you can find the coordinate that I'm asking you to, that will allow you to find the 6 trig functions corresponding to the angle in that picture. So that'll be the next thing that we do. Is I'm going to tell you what the 6 trig functions are. You might have already heard of some of them, like sine, cosine, tangent. But now we want to be able to figure those out for an angle that you had drawn. Okay? And it's all going to be based on finding a coordinate. This is not the only way to think about trigonometry. Okay? This is called unit circle trigonometry. It's one way to do it. The disadvantage of this is it only works for angles that are multiples of 30 and 45. Because unit circle trig, once you get good at it, it's kind of something you do in your head. It's like a visual. You draw a picture, kind of imagine where the point would be, and you go from there. Right? So like you could ask me a problem like if you gave me an angle that's a multiple of 30, 60. And you could ask me, like, find the cosine of 60. Well, right away, I can take a picture, draw that, it's a half. And what I did in my head was about 3 or 4 steps. But I've done those steps a lot. So I know that the cosine of 60 is 1/2 or 0.5. Right. So it gives me a way to figure out trig in my head if the angle is a multiple of 30 or 40. Right. So let's see how I did that. So when we talk about trig functions, there are 6. The 3 on the left are the basic ones, and you got buttons for all these on your calculator. You got a sine, you got a cosine, and you've got a tangent. Now, if you want to find the sine of an angle that's a multiple of 30 or 45, the way you do it is you find the coordinate, and the sine is the y value. That's it. The sine is the y value. If you want to know the cosine of an angle, it's the x value. If you want to know the tangent, you have to divide the two, y over x. Now, the other 3 trig functions we don't see or we don't use as much. The cosecant, the secant, and the cotangent. And the reason I wrote them the way I did, across from each other, is because there's a special connection between the one on the left and the one on the right in all these rows. Same connection. Right now, I don't have y as a fraction. How could I write y as a fraction? Yeah.
Y over 1.
Y over 1. Now, here's the relationship between what's on the left and what's on the right. They're reciprocals of each other. Reciprocal means to do what with a fraction? Yeah. Opposite means put a negative in front.
Flip it.
Flip it. The sine is the y value. The cosecant is the 1 over the y value. Cosine is the x value of a coordinate I'm going to show you how to find. What do you think the secant is?
1 over x.
1 over x. The tangent is the y value divided by the x value. So what do you think the cotangent is?
X over y.
X over y. So all the definitions that we need for unit circle trig are right there. You don't need anything else. All you need to know how to do now is find a coordinate. And that's the next step I'll talk about. Now, what's the name of this section again? I know it's 6.2, but what's the name of it? Yeah?
Unit circle trigonometry.
Unit circle. What does that mean? Unit circle. Talked about that at some point last week. Emily? It's a circle with a radius that's a specific number. You're thinking of, I know what you're thinking of. You're thinking of something else, but it's a circle that has a radius of, Chris? No, not pi. Yep, 1. So in this picture, it's 1 unit to get to the edge of the circle starting from the center. I'll come back to that. So, there's a special name for these 4 angles. These are called quadrantal angles because they are on the axes. And the axes divide the plane into quadrants. Quadrantal angles are 0, 90, 180, 270. Those are the easiest angles to find the coordinate. Let's look at 90, for example. Okay, I'll just do it right here. Here's my initial side. Where would the terminal side be for a 90-degree angle? Up on the y-axis, not down. Down would be 270, but up. There's a 90. right there is the point where the terminal side hits the circle. I want to know the coordinate for that point. Well, you haven't gone left or right at all. You've gone straight up. And how far up do you have to go, starting at the origin, to get to the edge of the unit circle? Yeah. Sure. So, what's a unit circle again?
It's like the circle that holds the angle or whatever.
So a unit circle is a circle with a radius of 1. So knowing that that circle has a radius of 1, what do you think the coordinate would be for the point that I'm pointing to? Yeah?
0, 1.
0, 1, exactly. That is always the coordinate for 90 degrees. Never changes. 0, 1. What would this angle be over here? Just tell me the angle of the 4 that are up on the board. Yep. That's 180. Jacob, what do you think the coordinate would be for 180?
-1, 0.
-1, 0. Yep. This one down here is 270. What do you think the coordinate is for 270? Yeah.
0, -1.
Mm-hmm. X is 0, y is -1. And then this is the coordinate for 360. But 360 is the same as 0. Eric, what do you think the coordinate is for 0?
1, 0.
Yep. The x is 1, the y is 0. Those are the easiest 4 points to get the coordinate. They're all 1s and 0s, or -1s. So now, if I asked you, for example, to say find the sine of 90 degrees, step 1 would be find the coordinate for 90 degrees. Step 2, well, let's start with step 1. Step 1, find the coordinate. Now, I'm going to start you guys off with some problems where I already give you the coordinate. So if the coordinate isn't provided, it's your job to figure out the coordinate. I've shown you how to find the coordinate for the quadrantal angles. I have not shown you how to find the coordinate yet if it's not. That's the second part of the lesson. Okay? This is pretty much the end of the first part. So, step 1, find the coordinate. Step 2, plug your coordinate into the formula. Which formula? Whichever one they want to know. If they want to know sine, you need the y value. If they want to know cosine, you need the x value. If they want to know tangent, you'd need the y divided by the x. Okay, what we're going to do, and the way I do these problems at first, is we're going to practice all 6. We'll do the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Okay, but on a test, or when you guys see this stuff on the midterm, I'm going to ask you for 1 trig function per problem. I'll just say, like, find the cosine. That's it. Okay, 1 thing. So, find the coordinate, plug it into the formula. All right. Now, you guys should already know what that angle is. You don't need to know the angle. What you need is the coordinate, and they gave it to you. This coordinate represents some angle. Even if you don't remember what it is, it's fine. You don't need to. It's important that you have the coordinate, though. So, we're going to find the 6 trig functions of the angle represented by that coordinate. Remember, this is all about an angle. Okay? Now, I'm going to put theta. I'm going to pretend like I don't know what the angle is. But can someone remind me what is 0, 1 again? It's really the coordinate for what angle? Yeah. It is. It's 90. You don't have to know that. Okay? But it is. It's 90. So, you're finding the sine of that angle. The sine is a Elias, which letter is sine?
Letter.
Yeah, in our formula. So out of those 6 formulas, I need the one for sine. Sine is the y. Sine equals y. So, in this case, the answer is 1. You're done. That's how you find the sine. Cosine. Kaya, what's our formula for cosine? It's the x, and what's the x here? Zero. There's your cosine. Now your tangent. Akira, what's the formula for tangent? Y over x. It's basically dividing the 2 you just wrote up above it. That's y. The one below it is x. Y divided by x. What's 1 divided by 0? Undefined. Yeah, you can't do that. Can't divide by 0. Okay, now the next 3. Cosecant, secant, cotangent. Remember, the Greek letter that I'm writing here, theta, represents the angle that you would be plugging into the sine function. So for example, you guys told me this is the angle for 90. You don't have to know that. But you knew it because of some other stuff I already showed you. So if you typed in sine 90, you get 1. Cosine 90, you get 0. That's what we just figured out. Tangent 90, you get an error because you're trying to divide by 0. It's undefined. So we're figuring out all the different trig functions of 90 degrees. It's basically what we're doing. Now, what's the connection with the ones on the right if you have the ones on the left? All you really have to do is take the ones on the left and flip them. So when you flip 1, it's still 1. Now, 0 is not a fraction, but you can make it a fraction. If you flip 0 over 1, that'll give you your secant. So what would you get when you flip 0 over 1?
1 over 0.
1 over 0, undefined. So when you flip 0, you get undefined. What about when you flip undefined? What do you get? Nope, the only things you can flip that stay the same are 1 and -1. If you flip one of those, they stay the same. Everything else is different. So if you flip, look at the one above it. If you flip 0, you get undefined. If you flip undefined, you're going to have 0 divided by 1. You have $0 to give to one person. How much is that person going to get? 0. And those are the 6 trig functions for the angle represented by the coordinate 0, 1. Now, you guys knew what the angle was here. It was 90. You don't know what the angle is here. I'm guessing most people don't. I know what the angle is. But it's not important that you know the angle. You don't need to know the angle to do any of this. You need the coordinate. And that's what I've given. Okay, start with our sine. Sam, what's my sine going to be here?
It's going to be square root of 3 over 2.
Yep, sine is my y. Cosine is going to be my x, so that's a half. And Caleb, what's my formula for tangent?
It's going to be square root of 3 over 2 over.
Right, it's going to end up being a fraction over a fraction. Well, when you divide 2 fractions, if they have the same denominators, those cancel out. Some people think of it as keep that the same, flip and multiply by the reciprocal. That's the same thing. So the 2's would cancel out, and you're left with square root of 3 divided by 1, which is just square root of 3. Okay. Now, Emily, what do I have to do with the 3 on the left? to get the 3 on the right. Flip them. So when we flip the first one, we get 2 over the square root of 3. But there's a problem with that. What's the problem with 2 divided by the square root of 3? You're not supposed to leave a square root in the bottom. So we fix it by multiplying top and bottom by the square root of 3. So that gives you 2 root 3 over 3. Eventually, you'll probably have that memorized because this number isn't a random number. Square root of 3 over 2. It's going to come up a lot. In fact, every angle that's a multiple of 30, you're going to see the square root of 3 over 2. So that's kind of a hint. This angle, this coordinate, it's the coordinate for an angle that's a multiple of 30. Not going to tell you which one. You'll find out. Okay. The secant, that's not as bad because all we have to do is flip 1/2. Brianna, what do I get if I flip a half? 2. Done. And the cotangent? Well, I need to flip square root of 3. But Eric, how can I make that a fraction?
Square root of 3 over 1.
Yeah, you could just put it over 1. So when you flip it, you get that. Anyone think they can tell me what you get when you fix it so the square root isn't in the bottom? And you've got to fix it the same way you just did cosecant. Yep.
Square root of 3 over 3.
Exactly. Square root of 3 over 3. So there are your 6 trig functions for some angle, which I didn't tell you, represented by this coordinate. If you really want to know what the angle is, it would be 60 degrees. That's the coordinate for a 60-degree angle. So try it. Take the cosine of 60 on your calculator and see what you get. You'll get 1/2. If you do it in degrees, not radians. Okay. Now, this one's a little different. This one is an extra step. What haven't they given you here that you really need to have? Yeah. You don't have the x and the y. They gave you the angle. That's no good. You need the coordinate. So what I usually do is if I can't remember it, I make a sketch. I say, okay, where's 90? That's at the top. And now I have to look at that and find my coordinate. So Jacob, what is the coordinate for 90 degrees? 0, 1. Now this problem is just like the last problem. Sine is y, except the numbers are a lot nicer. Cosine is x. What about the tangent? Yeah. 1 over 0. This problem should look very familiar. We've already done this. The coordinate is 0, 1. That's the problem you guys just did. Example 1a. So we've already done it. The only extra step is you had to find the coordinate first. So I'm not going to finish it. But once you find the coordinate, you're good. Do it just like we did example 1a. So I'm going to put in parentheses. It's the same problem. Okay, let's look at this one. 270. There's 270. What would be the coordinate for 270? Yeah, Chris?
0, -1.
Yep. And Nikara, what would my sine be? -1. -1. Cosine, Ko? Yep, 0. And the tangent? -1 divided by 0. Can't do that. Undefined. Emily, how about my cosecant? Which is what? -1. Yep, stays the same. Sam, what about my secant?
Would be 0.
Well, it can't be the same as as this. We have to flip that. So what do you get if you flip 0?
Oh, 1. 1 over 0.
1 over 0, which is undefined. And Caleb, how about my cotangent?
0.
And what is 0 divided by 1? Correct. So anytime you're working with a quadrantal angle, your answer is 1, -1, 0, or undefined for all 6 of these. Always. When you start working with the 1/2 and the square root of 3 over 2, then you get some different stuff. You'll never get undefined with those. The only way you get undefined is if your coordinate has a 0 in it somewhere. And the only coordinates with zeros are here, 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 and there. Okay. How about pi? Okay, first step here would probably be to think of pi in degrees. What is pi in degrees? Yeah?
180.
It's 180. And what's the coordinate for 180? Yeah? -1, 0. And you'd go through and do the same thing we've been doing. Sine is your y, cosine is your x, and tangent is your y over x. And to get the other 3, flip, flip, flip. Same idea. Okay, let's look at 7 pi over 2. So Jared just told us what pi was. What's pi divided by 2? Yeah? 90. What's 90 times 7? Yep.
630.
630. I don't like that angle. It's too big. I gave you guys a trick last time. If you get an angle that's too big, you can do something to it to make it smaller. What can you do to 630 degrees to make it smaller? But it won't mess up the answer if you do this. Yep. Exactly. You can subtract 360. And that's 270 degrees. Oh, what's the coordinate for 270? You guys just did that wrong. It's example 3. So we've already done this problem. Okay? I just wrote the angle a little different, but it's the exact same problem. So I'm just going to put here, that's example 3 again. Let's look at this one. I don't like that angle either. What can I do to -90 to fix it? I've got kind of the opposite problem this time. Chris? Add 360, and you're going to get 270. Well, look at that, 270 degrees. That's another way of doing the same problem again. It's example 3 for the 3rd time. So you can see if I give you problems about quadrantal angles, there's only 4 different kinds of problems I can give you. I can try to make the angle look different, but if you add 360, you're going to see it's the same as something else. So any question on that? Okay, so that's the it's 6.2 part 1. Okay, so for on page 335 so far, just write that down. Page 335, 158. Okay, I'm going to add a few more to that. Page 335, 158. All right, now in part 2, we're going to look at not only finding the coordinates for the quadrantal angles, but now we're going to look at finding the coordinates for the angles 30, 60, and 45. And if you can find the coordinates for a 30, a 60, and a 45, then you're going to be able to find the coordinates for any multiple of those angles. If you can do 30, you can do 120. You can do 45, you can do 135. It's just 45 times 3. So 30, 60, 45. Okay, so we'll look at that. And then we'll see what we get to on that. This is kind of separate. I'm not even sure why they really put it in this section. It kind of ties in a little bit, but we'll see if we have a chance. This part takes about 5 to 8 minutes. So I'm not sure we'll get to it. We'll see. We're going to spend a whole week on this section later on. Trig Identities. It's not critical if we get to it now. It's kind of like a little preview. All right, so I'm starting out with my 45, 45, 90. So what I've done is, this is 0. We already know the coordinate for 0. We already know the coordinate for 90. Now I want to know this coordinate. Well, the way to find it, at least the first time, and then after this time, we should just try to remember what it is to make a triangle. Besides that being a right triangle, can somebody else tell me what kind of triangle I just drew? Keep in mind, this would be a 45. That's the angle from the x-axis to the hypotenuse. Yeah?
Isosceles?
It is. That's an isosceles triangle because all the angles have to add up to 180. 45, 45, 90. That's what it would have to be to add up to 180. Isosceles means what? Chris? You're thinking of, that's a straight angle. Isosceles has to do with something about a triangle, something special. Yep. Yes. And in fact, this side and that side are exactly the same. Now, there's a side I already know here. How long is the hypotenuse in that triangle? Because it's in the unit circle. The hypotenuse is really the radius of that circle. Yeah? It's 1. So, to save a little bit of time, what I'm going to do is, I'll just tell you what you could do. If these two sides are the same, you really don't have to use different letters. But you could set this up. What formula did I just use? Gary?
Pythagorean Theorem?
Yeah, Pythagorean Theorem. You can use the Pythagorean Theorem to find the length of the side. Remember, x and y are exactly the same. And if you use the Pythagorean Theorem, what you will get is the following coordinate. Square root 2 over 2, comma, square root 2 over 2. That is the coordinate for a 45-degree angle, and that never changes. Okay? Again, using the Pythagorean Theorem is how you prove that. We're not going to go through that part of the proof. It'd take an extra minute or two, but chop that off. Okay, so that's a coordinate you want to remember. Square root 2 over 2, square root 2 over 2. Now, when we were doing part 1 of 6.1, hopefully you guys noticed this problem. A 1/2 and a square root of 3 over 2. And I told you that it had something to do with multiples of 30. And now I'm going to show you exactly what. First of all, look at the difference between the 30 and the 60 triangle. Did anybody notice the difference between them? Like if you were to cut both of these triangles out and then line them up, how would they compare? Brianna? They're exactly the same. This triangle is really just this triangle standing up on its standing up tall rather than laying down on the long side. But they are the exact same triangle. So what does that mean about the coordinates for the 30 and the 60? Are the coordinates exactly the same? So this point is exactly the same as this point. What do you think the difference is going to be? Emily? Well, the x value is going to be further away in one of them, and then the y value is further away in the other one, or bigger. But if you were if you knew this value, I'll just put a check mark, and this value, and then you knew this value and this value, what's going to happen to the check mark and question mark in the 30 when we rewrite it as the 60? Yeah?
Just gonna switch places.
They're just going to switch places. That's all that's going to happen. So the two numbers that you have to remember for the 30 and the 60, and I could prove this to you with Pythagorean Theorem, are 1/2 and square root of 3 over 2. Now, 1/2 is what as a decimal? 0.5. Square root of 3 over 2 is about, if you divide that on your calculator, 0.866. Which one is bigger? Yeah, square root of 3 over 2 is bigger. So, let's look at the 30-degree angle first. There's one side of the triangle. Here's the other. Is the red side or the green side bigger? Which one? Red. The red side gets the bigger number. It's going to look confusing. Square root of 3 over 2. The green side is shorter. It gets the smaller number. Now you just make sure you put those numbers in the right spots. Red is horizontal. That's your x. Green is vertical. That's your y. Now, look at the same thing in the 60. There's your short side in blue. Here's your long side in black. The short side gets the short number. The long side gets the longer number, or bigger. So this time, for the 60, the short side is now on the bottom. So the bottom is 1/2. And the tall side gets the tall number, big number, 0.86 square root 3 over 2. So all that happens in a 30 and a 60 is the x and the y switch. So for unit circle trig, in this section, there's 3 numbers you got to remember. You got to remember square root 2 over 2, which has to do with 45-degree angles. Square root 3 over 2 and 1/2. Those two always go together, and they have to do with 30-degree angles. Again, I did not prove where those come from because that would take another 5 minutes or so. Okay, but those are the coordinates. So now, whether you really knew it or not, when you did this problem in the first section, 1/2 comma square root 3 over 2, you found all the trig functions of 60 degrees. And I think I said that in the video. Okay, so let's try an example. Okay, find the 6 trig functions of 45 degrees. Okay. In order to do anything with unit circle trig, Jared, what's the first thing you have to have?
Coordinate.
Yes, you need the coordinate. So, Jacob, what's the coordinate for 45 degrees? Anyone help them out? On that diagram that I drew, not the one we just did, that was 30 and 60. What did I say the coordinate was for 45? Yeah. Square root 2 over 2, comma, square root 2 over 2. So, you got your coordinate. Now we can do anything they want. Okay. So, Nikara, what would my sine be? Yep, and this time they're the same, so if you mix them up, you'd be okay, but it's the y. Square root 2 over 2. Chris, my cosine?
Square root over 2.
Square root 2 over 2. And Kea, for my tangent, I have to divide the y by the x, but they're the same. So what do you get when you divide two things that are the same? Now let's do the cotangent just because that's a quick one. What do you get when you flip 1? 1. Now the cosecant. It's going to be 2 over the square root of 2. But I can't leave the square root in the bottom. So Caleb, what do I have to multiply the top and bottom by to fix that? Square root of 2. And you get 2 square root of 2 over the square root of 4, which is 2. Well, what happens there? What simplifies? Which ones? Which one in the top? Yes, the 2 on the outside of the root cancels with the 2 in the bottom. So all you're left with is square root of 2, which now should make the secant very quick. What's the secant? Right, the sine and cosine were the same. So the secant and the cosecant are also the same. So that's the 6 trig functions of 45 degrees. Let's try this one. I don't feel like really doing all 6, so we'll just do the first 3. The sine, the cosine, and the tangent. Okay. What's the first thing I have to figure out here?
Coordinate.
I need the coordinate. Now the 30 and the 60, that's the one you got to be careful. It's either 1/2 root 3 over 2 or root 3 over 2 1/2. You gotta get that order right. So if you draw your picture, mark the 30 and draw it somewhat to scale. 30 is less than halfway. Here's your triangle. There's the long side, there's the short side. Which side in that triangle is the longer one? The base or the height? The height is longer? The base. Yeah, the base is longer. And the longer number is always which one? In any problem that involves a multiple of 30. Yep. What number?
Oh, square root of 3 over 2.
Yeah, there you go. Square root of 3 over 2. And the height is the short side. So we're dealing with an angle that's a 30 degree. In a problem involving a multiple of 30, how long is the short side? 1/2. So your coordinate is x comma y, square root 3 over 2, comma 1/2. You guys basically did a problem like this in part 1, except now I just switched the x and the y. Okay. So what's my, Emily, what's my sine? 1/2. What's my cosine? Caleb?
Square root of 3 over 2.
Yep. And my tangent? I'm going to divide the y by the x. 1/2 divided by root 3 over 2. Now, if I divide these two fractions, just imagine putting a division line right there. What would cancel out right away? The 2's. So I would have this, and then I would fix it to that. And to get the other 3, you would flip them. Let's look at this one. Pi over 3. Remember what we did in radians. Pi is 180. So what is, what's 180 divided by 3? 60. So now, in my head, I'm trying to think of what a 60-degree angle looks like. 60 is up here. Make your triangle. 60 is more towards the top. How long is the bottom side?
1/2.
1/2, because you're dealing with a number that is a multiple of 30. So you're going to use the 1/2. And what's the other number you always use? The bigger number. When you have a multiple of 30. Yep.
Square root of 3 over 2.
3 over 2. And Sam, can you tell me what the coordinate would be for 60 degrees?
It would be square root of 3 over 2.
That's your y, right?
Or, yeah, well, we have square root of 3.
So 1/2, comma, square root of 3 over 2. And now look at that coordinate. 1/2, comma, square root of 3 over 2. You guys already did this problem. 1/2, comma, square root of 3 over 2. We did all 6 of them earlier. The only difference is earlier I gave you the coordinate. You guys didn't know that that was for a 60-degree angle. Now, you had to find the coordinate yourself. But the work is the same. Okay, let's look at 135. Now, there's only 2 types of triangles we're dealing with. Either it's a triangle that has a 45-degree angle in it, or it's a triangle with a 30-degree angle in it. 135. Do you think that number is a multiple of 30?
No.
No. Multiples of 30 are going to end in a 0. Is that number a multiple of 45?
Yeah.
Yes, it's 45 times 3. So, let's make our circle. Here's 90. Here's 180. Where's 135 in relation to those two numbers? Yeah.
Halfway through 90 and 180.
It's halfway. So 135 is right there. That's 135. Now, I'm going to take that triangle and just make it a little bigger over here. How far is it? Well, Jacob kind of told us because it's halfway. How far is it to get from 90 to 135? How many degrees?
45.
45. So if this part is 45, then how much is this part inside here? 45. You've just drawn a 45, 45, 90 triangle. Now we just have to remember how long each side is. Each side is what number in this triangle? It's not the 1/2 root 3 over 2. It's the other number. Yeah? Yes, they're both square root of 2 over 2. But we've got to be careful. Look at where your coordinate is. When I write the coordinate for 135, what should I be careful about with the x value? Yeah? It's a negative. That's the only difference with doing what we just did in the first quadrant in any other quadrant. All the coordinates are the same. Sometimes you have a negative in front. That's it. So now for 135, it's negative root 2 over 2, comma, root 2 over 2. And now we can do all the trig functions. We're just going to do the sine, the cosine, the tan. Nikara, what's my sine? Positive. Why? Chris, what's my cosine?
Negative 3 over 2.
Yep, negative root 2 over 2. And my tangent, I'm dividing two things that are opposites. So what do you get when you divide opposites?
Negative
Negative
1.
1. And you could flip them all to get the other three. That's it. It's 135. Let's try this one. Now you can multiply by 180 and divide by pi, or anyone remember what pi over 6 is? Or pi is 180, so what's 180 divided by 6?
30.
30 times 7. It's 30 times 7. 210. Now let's sketch that and see what kind of angle we're dealing with. Here's 180. Here's that. That's 180. Here's 180. Here's 270. Where's 210? Your options are right in the middle, closer to 180, closer to 270.
Closer to 180.
It's closer to 180. It's right here. There's your triangle. How far past 180 do you have to go to get to 210? Yeah. 30. So this triangle is the 30, 60, 90. Here are your two sides. Can somebody tell me the long side? The long side is always what number? Chris?
Root 3 over 2.
Root 3 over 2. I'll come back to it in a second. And how about the short side? Yeah. 1/2. Now, you're finding the coordinate that's in the third quadrant. So both your x and your y should be what? Negative. That's it. Everything's the same from here. Negative. Negative. So Sam, what's my sine?
It would be square root of 3 over, or negative 3 over 2.
That's my cosine. So cosine is the x. Sine is the y. And now just imagine putting a division line right there. If you divide them, what would cancel out? 2's and what else? The negatives. So I'd be left with 1 over the square root of 3. 1 in the top, square root of 3 in the bottom. And does anyone remember what that turns into when you fix it? It's come up a couple times. Square root of 3 over 3. Good job. Okay, so if your angle is a multiple of 30, it's going to involve the 1/2 and the root of 3 over 2. If your angle is a multiple of 45, root 2 over 2. Now, what if I said to you, find the sine of 52 degrees? Well, that's not a multiple of 30 and it's not a multiple of 45. So what are we going to do? Use the calculator. Right, so if you're asked to find a sine, a cosine, a tangent of anything that's not a multiple of 30 or 45, all you have to do is type it in on the calculator. Biggest thing you got to be careful about is make sure you're in the right mode. Example 6a is a degree problem. Example 6b is a radian problem. I know it's radians because there's no degree symbol. Okay, very, very easy to do. I'll show you how to type it in. Okay, to type in sine of 42, you type it in exactly the way you see it written. Press sine button, press 42, close your parenthesis. I'm already in degrees. If you got 0.669, you did it right. That's it. Let's do cosine. Cosine 42. You should have gotten 0.743. Why am I round? Well, actually, it said round to 2 decimal places, so I'm not really following what it said to do, but that's okay. And tangent of 42, 0.900. Now, look at the buttons on the calculator. Do you see a button that says CSC, SEC, or COT? No. There are no buttons for those. So you have to find the 3 on the right the same way we've been doing them all class. What do you do with this number to get this number? Flip. That's it. Take it and flip it. So you can type 1 divided by. If you want a more accurate answer, you can just do 1 over the sine of 42. 1.49. I'm gonna start doing 2 decimal places because that's what it said. How would I type in secant of 42? Yeah.
1 over 0.743.
Yep.
Or sine.
1 over the cosine of 42, which is 1.35. And Emily, how about the tangent? The cotangent, sorry.
1.
So remember, we don't have an x and a y because we weren't able to get this coordinate because it's a weird angle. So we have to get the cotangent using the same idea. So in general, what do you do to get the one on the right if you have the one on the left? Yes, just flip it. 1 divided by tangent 42. 1.11. Now, this one I'm not going to go through. I already kind of told you. But what's the big difference here you'd have to do on your calculator first? Like if I type 1 divided by sine 10 right now, it's wrong. What do I have to do here? Yeah.
Go to mode and change it to radian.
Right, radians. So you want to make sure you change your calculator to radians before you do this problem. Any question on that? Okay. Yeah, we're not doing the trig identities. I'm going to skip that because we're going to spend a week on that later. Okay, so yeah, we'll finish with this. So, I don't know if I've shown you guys a picture yet of sine or cosine, but this is how they look. Let me get a better window than that. Usually when you graph a trig function, we do zoom 7. Sine and cosine are waves that go forever left and right. You never have to pick your pencil up to draw it. So that means it's continuous. But they don't go forever up and down. The highest they go is 1, and the lowest they go is negative. That's sine and cosine. And now, the last thing is, what did I say earlier that you can add or subtract over and over and it won't mess up your answer? 360. So if I did the sine of 10, I get that. What's 360 plus 10? 370. It's the same thing. If I add another 360, 370 plus another 360. You get the same thing again. What's 10 minus 360? Negative 350. What I'm trying to show you here is it doesn't matter how many times you add or subtract 360. You will get the same answer over and over and over. That's what this top thing says. If you want to take the sine of something, or take the sine of that something and add 360 as many times as you want, you can add 360 times 1, 360 times 2, 360 times 10, 360 times 100. You can add 360 as many times as you want, and you will always get the same thing. And it works exactly the same for cosine. In radians, you can add 2 pi as many times as you want, or 360. That's what this is. Okay. So taking the cosine of 10 is the same as the cosine of 10 plus 360. Same as the cosine of 10 plus 720. Cosine 10 plus 360 times 3 plus 360 times 4. Doesn't matter how many times you add it. You'll always get the same answer. And that's called the periodic property of sine and cosine. So yeah, I think we got to a good spot because the very last thing is trig identities, which again, we're going to spend a whole week on that later. So no reason we got to look at that now. What were the first 3 problems I gave you guys? 1,
5 and 8.
1, 5, and 8. So we're going to look at trig identities another time. So you don't have to do that. And let me see if there's anything else you don't have to do. You can skip that one. And yeah, you do need to calculate, like 37, 39, you just punch in something on the calculator. Those are quick. Yeah, I think everything else is okay. Okay, so we got through all of 6-2. So next Monday, a week from today, we'll go over that homework, and we will finish 6-3 by Wednesday, and we will have a test on Thursday, and we'll do something different on